Now let's go for try it now 5. And the question says, a website says that you will need 48, okay, let's try it now 5, 48 50-pound bags of sand to fill a sandbox that measure 8 feet rather, 8 feet by 8 feet by 1 feet. Okay. How many bags would you need for a sandbox 6 feet by 4 feet by 1 feet? All right. So what are the informations we have? We have a sandbox. Let's say this is our sandbox. I'm trying to draw it for you. We don't need to do that though. Uh, okay, let's say that's your sandbox. Um, and the measure of that, 8 feet by 8 feet by 1 feet. So let's say that's 8 feet. That's 8 feet as well. And this is 1 feet. Okay. So we know the measurements. Someone is in the waiting room. Give me a second. Okay. Yeah. Now we need to find how many bags would you need for a sandbox of 6 feet by 4 feet by 1 feet. So let's say we have another sandbox smaller than this one, clearly because you can see the measurements. Okay, so this one has a measure a length, I guess 6 feet by 4 feet, and let's say this is 1 feet. Okay, so these are the measurements we have. For this particular sandbox, we need 48 bags, right? And for this one, we are looking for how many bags will it require to get filled, right? Oh my God, it's difficult to look at the waiting room at the same time. Sorry for those interruptions. I need to let them join. Okay, now what are the informations we have? We have the measurements of those sandbox, and for one of these, we have the number of bags it needs to get filled, and for the other one, we'll try to find that. Now, how can we set up the problem? Once again, that's the second thing. The first thing is we need to find what are the informations we have in our hands and put those in the right places. You don't need to draw this though. This is just for uh, visualizing. If you try to visualize this, you can imagine this, that's fine. You don't need to draw this, but I'm drawing this so that you can see what's going on. All right. Now, we have the information in our hand, and the next thing we need is to uh, see how can we use the formulas we know. Okay, now how can we do that? Anyone? What are the formulas you know, and how can you relate those to this problem? That's
We know
yeah.
the formula for the volume of a cube or like a rectangular prism, so we could use that to find the volume of the sandboxes.
Okay, so why do you think we should go for the volume? What made you think that?
Because they're 3D objects and we have the three measurements for each of the sides. So we're not finding the area, we're finding their depth and width.
Um, I think I've said this the last time we met. I would like to repeat that. Often in a problem, we try to confuse the students with more information than they need. So um, even though we have three measurements, I mean 3 dimensions, uh, is there anything else that you could think that we should go for the volume instead of just looking at the 3 dimensions? Because often if I go for the surface area, I might not need those 3 dimensions. So my question is, the reason I'm saying this is, uh, obviously you need to eyeball the informations you have, but doesn't really mean that you need to use all those informations. Often you don't need this, but we try to, as I said, confuse the students so that they overthink and do a mistake. Okay, so as you are trying to fill those boxes, that means you are actually capturing the entire, you know, uh, space in that box. That means the space it's actually covering, and that's what uh, made me think that yeah, it's the volume, not because the 3 dimensions are given, right? Does this make sense?
Yeah, that makes perfect sense.
Yeah, right. You had almost got it right, but as I said, it might not be the case all the time. So as I'm trying to fill it, I'll go for the volume. So the volume of this, what's the formula for this? Let's say that's the volume of the big sandbox. I'm writing as VB, and that's the smallish one. So what's the formula for an object like this? Anyone else? Just go for it.
It's length times width times height.
Very good. So it will be length times width times the height, right? And as all of these are in feet, it will be this. This is the unit. So for the exam, for the free response question, of course, you need to have the right unit as well. Otherwise, you might get penalized, right? This is really important. You need to have the right unit at the end. All right. So this is going to be 64 cubic feet or feet cube, the way you like to mention. Doesn't matter as long as you write it in the proper place. What else? What is the question again? Sorry. Okay. Now the volume of the smallish box. So once again, it will be length times width times height. So it's going to be 24 cubic feet. All right. Okay. So now we have the formula. We have used it to find the volume. Now what's next? How can we set up the problem to find our unknown uh, variable, number of bags we are looking for in particular here? How can we set this up?
Would you put 64 over 48 equals 24 over x?
And how did you do that?
I used the two volumes from each of the sandboxes
Okay.
on the top and then the amount of bags for the bottom.
Very good. Yeah. So once again, we'll use the proportions, the ratio of the volume and the number of bags for the first one. And definitely we'll copy that on our right as well, because we need to have the same unit and the same ratio. Obviously, if we take the same ratio, we'll have the same unit anyway. So this is the equation. Now we want to solve it. And how can I solve it? Once again, we can cross multiply it. Let me use different color for it. So we can cross multiply this to get 64x, and we can do this. So this will be okay. Let me keep it like this so that I can cancel this out somehow in the next step. Now I'm trying to isolate the x. So what I'll do, I'll divide both sides by 64 since I am trying to isolate the x. So clearly it's going to be, let me write it for you. Clearly it's going to be 48 over 64. So finally I'll have, if you solve it, you'll get 64, right? So it's 8 times into this, and it's 6 times into this. It will be 3 times into this, so I think it will be 18. So as per my calculation, you will need 18 bags of 50 pounds to fill that smallish box with sands. Okay. Okay. Any question from this?
Yeah, I had a question.
Mhm.
How did you get 48 again?
In the denominator?
Yeah.
Okay, so I'm taking the ratio of the volume and the number of bags the box needs to get filled. So this 48 is actually given. This big box, the sand box, needs 48 50 pounds sand boxes, rather sandbags, to get filled.
Okay, thank you. Yeah, I missed that.
No problem. All right, what's next? Anything from the study guide, although those are really examples and exercises, and that should be enough, as I said. So have you found any problems from those? Is there any problem which you want me to solve? Otherwise I might pick problems randomly if you don't have anything in your pocket right now. No problems at all? All right, so let me pick a problem randomly, and meanwhile, if you find any question, we can go for that once we finish this one. Okay. All right, so let's do a problem. Okay, let's start with an easier one. Okay, and it's exercise 3. Let's try 3. It's a good problem. Okay, so it's on page 18 if you want to see the question. Exercise 3, it says Ireland has a 23% VAT. How much will the VAT be on a purchase of a pound, or it should be euro, right? Yeah, euro 250. Okay, so 250 euros, and we're trying to find the VAT imposed on that. Is it pound or euro? It's euro, right? Anyone? I think that's euro. Anyway, we don't really need that particularly, but it's good to know. All right, so now for the first question is, what does it mean to have 23% VAT? What does that mean? That's the first thing we need to understand before we go any further, right? Anyone? Okay, let me ask from the participants list. Uh, Veronica, are you here?
Yeah.
Okay, so what do you understand by this 23% VAT?
I'm not sure.
No problem, go ahead. Just anything that you can uh, make out of it.
I'm not sure exactly what the VAT part is, so that's what I'm
No, forget
confused
about the
on.
VAT. Forget about VAT. What do you understand by 23% of something?
That it's like 23% of like 100. So like, yeah. So if it was like a fraction, I think it'd be 23 over 100, right?
Right.
That's like,
Yeah.
that's what I would know about it. I don't know.
No, you're doing fine. Exactly. So if you have anything on a scale of 100, you would have got 23, right? That's what 23% means. Whatever the thing is, the object or whatever it is, if the scale is on 100, you would have got 23. Okay, so that's what 23% means. Now, this VAT part is actually the tax, the sales tax here uh, in the United States. And once again, if you go to Walmart or Ridley's or Safeway, wherever you want to go, uh, when you are paying the amount, you'll see there is a little amount just below your entire amount is called tax. I guess it's 6.02% in Wyoming. So if you buy something worth $100, you'll see you are actually paying $106.2. So that extra $6.2 is actually the sales tax. So that's similar. This VAT is kind of similar, although it has different significance. We'll not go deep into that. That's not a mathematical thing though. So this VAT or sales tax means if you buy something of worth 100, you need to pay this amount, whatever the percentage is. And it varies, of course. It varies uh, to states. If you go to different states, you'll have different percentage. If you go to different countries, you'll see even more discrepancies, more differences rather. All right, so now someone has bought a product of 250 euros, okay, and we want to find what's the amount he needs to pay as VAT. Now, how should we do that? What are the informations we have? We know if the product is worth 100 euros, we need to pay 23 euros as VAT. And from that, we are trying to find if we buy something of 250 euros, what's the VAT going to be? How should we do that?
Would you multiply 250 by 0.23?
Okay, so 253, you're saying by 0.23. And why do you think we should do that? I mean, what made you think that?
Because that way you're taking 23% out of 250, or yeah, 23% out of 250 euros to give us.
Exactly. So if you go back, I guess it's page, let me see. What was the page number? Okay, so if you go to page 2, at the very beginning, you have a box with percents, and there you can see the equivalent formula. That means if you have a percentage, how can you find the part of that, and the vice versa as well. So as we're looking for the part, I mean the VAT in this case, all we need is the percent times the whole amount. Okay, that's the formula for a particular portion of it. So the percentage is 0.3. Obviously, you need to do that in decimal. So 23 over 100 will give us 0.3. And the whole amount is 250. So you're absolutely right. This is going to be the answer. And if you can use the calculator, which you can obviously during the exam, let me use my calculator. 250 times 0.23, it should be 57.5. Okay, so that means if you buy something worth 250 euros, you need to pay 57.5, that means 57.5 euros as tax, or VAT rather in this case. So that's the amount we are looking for. Okay. Okay, let me see whether it wanted the entire amount or just the VAT. Let me quickly go back to the problem. Okay. So how much will the VAT be on a purchase? Yeah, it's just looking for the VAT. It's not looking for the entire amount you need to pay, including the VAT. Okay, so just looking for this amount, 57.5. The question could be slightly different if I just say how much will he need to pay on a purchase of 250 euro. So as you can see, I've just removed that word VAT, and now the question will be completely different. If you just keep it like this, then you'll definitely be penalized. So if I say how much will he need to pay on a purchase of an item worth 250 euros, you need to do an additional step, which is 250 plus 57.5. So the total would be 307.5. So once again, I'm repeating myself, look at the question pretty clearly. One more word or one less word would actually mean a completely different thing. Okay. All right. Any question from this one? Anyone? Take your time, because these are really basic things, and I promised you that the question will be really easy. But if you know the concept, how these things are done, what are the methods we have seen, and obviously you'll have the formulas in front of you. So if you can relate those, I guess everyone will get a full credit. It will be a fairly easy exam as long as you know these stuffs. So if you have any question, you should go for it now. And obviously before the exam, even during the weekend, if you have any problem, you can shoot me an email. I'll try to reply as soon as possible. Okay.
So, like, where are we taking the exam? Like, where will the exam be? Like,
well, everything, the homework, the exam, everything will be on My Open Math. If you log in, you'll see the exam is there, and you can start doing that. You'll have a 50 minutes window once you start, and you will be given space for the free response question where you can write those stuffs. And for the multiple choice question, of course, you know that you just need to pick the right option. That's it. And I'll be there. I'll be in my Zoom meeting, Zoom ID, of course. So if you need any help during the exam, I'll be there. Okay, just shoot me an email. I'll just log in and talk with you if you just need any help. No worries.
Was there any homework assigned on My Open Math yet? I've found it kind of hard to look and see.
It should be. I think it should be on. Let me see. Just give me a second. Okay, so homework 1, what is that? Okay. Okay, so today is 5th, right? February 5th. Yeah, so it will be available from 10 a.m. Yeah, from 10 a.m. today. You can see that, and you can start working on those. There are only a few problems, so it shouldn't take much time.
And when will that be due?
It will be due on February 9th at 10 a.m.
Okay.
Mhm.
And then where on My Open Math will I be able to locate that?
So if you log into My Open Math after 10 a.m., it should be just at the top of your screen,
Okay.
as long as I can see. So it should be pretty similar. I can actually see the student view as well. So that's what I can see. It should be on the top of your page. And of course, if you can't see that, just let me know, okay? Because as like most of you, I'm using My Open Math for the first time as well. So we might need to take just a little bit of time to adjust things and all that. Okay. All right. So any other questions from this problem, or should we go for the next one? Any problems you want me to solve out of these exercises? Nothing as yet. Okay, let me pick another one. Okay, so let's try examples, exercise 7 rather, not example, exercise 7. And it says the population of a town increased from 3 to 50. That was in 2008, and in 2010 it increased to 4300. Okay, so in 2 years it increased from 3 to 50 to 4300. Okay, and now we want to find the absolute and the relative increase. Now what should we do? How can we find the absolute increase? What's the formula for that?
I think you should take the original population and subtract the new population, and then like do the absolute value of that for the absolute change.
Right. So the basic idea is when you're trying to find the change, the basic idea is to go for the ending value and subtract the starting value from that. But as we're looking for the absolute change, even if you change the order, you will get the same result. But we'll actually try to be consistent and do the same. So the absolute change of population, so let me write pop n, that's the population. Okay, so the ending value was 4300 minus it's 3250. So I guess we'll have 150, right? Oh no, sorry. Uh, okay, now what's next? I mean, this is the absolute change. So we are done with the first part. The second thing is we are looking for the relative Okay, they have already mentioned the word increase, although it's not going to be the case always. So on this occasion, we can clearly see it's increasing. So they have mentioned it, no harm in that, but it could be decreased in some cases as well. Okay, so what should be the relative change? What should be the formula? What's the formula we have used for that?
You're gonna take the absolute change and divide it by the original value, I think.
So that's the absolute change, that's the relative change. So you're saying that I'll take the absolute change over what?
Over the starting quantity.
Very good, yeah, over the starting quantity. So the formula is basically absolute change. Let me use the same notations. Absolute change over the starting value. Okay, so that should give you the relative change. All right, so if you can use your calculator, it should give you, let me see, over 3250, so it's 32.31%. I've skipped a step though. If you want, in between there is another step, which is 0.32307, and you can convert this to a percent. So 3231 over 100 times 100, and the numerator will give you, the numerator will give you 32.31, and the denominator will give you the percentage. So that's how I got this. Okay, so that's going to be the relative change. That means if you change anything of 100 units, it will increase by just about 32, because it's a population. We can't really have fractions, but it's just about 32. Okay, because we can't really have fractions, but we are doing math, so you can keep it like this. All right, any question from this one? This interpretation is really important as well. Okay, the question might want you to express what do you understand by this relative change or this relative increase. Okay, you just need to phrase it with proper words. Okay, you just need to use the right phrase for it. Okay, what's next? Let me find, I think we can solve one or two more. So okay, okay, now let's go for exercise 31. Okay, it's from the proportion part. Let's solve one of these as well. Exercise 31. Okay, it says a crepe recipe calls for 2 eggs, 1 cup of flour, and a cup of milk. How much flour would you need if you use 5 eggs? Okay. All right, now the information we have is 2 eggs, 1 cup of flour, and 1 cup of milk. Oh, sorry. This is what it needs. My question is, how much flour would be required if I use 5 eggs instead of 2? So these are the informations we have. And now we need to set this up. What should we do? Just think about it. Use your intuition. Try to um, find the relation between the given informations. If you can do that, the rest should be pretty easy.
Don't you just put the 2 eggs over the 1 cup of flour equal to 5 eggs over x?
Very good. So clearly, just as I mentioned, I think just about 10 minutes earlier, that you might have more information than you need. And clearly, as you can see, this cup of milk, number of uh, cup of milk is actually additional information. We don't really need that, right? So that's why it's really important you can find the relation, the exact relation you need, okay? So we can see if we take the ratio of eggs and flour, we should be going to the right direction. So for 1 cup of flour, we need 2 eggs. I'm taking the ratio of flour over eggs, okay? So on my right, I don't really know the number of, the amount of flour we need, so that's going to be our unknown x. And with it, we'll take the ratio of x, which is 5. Before we go any further, does this make sense, everyone?
I was wondering
Yeah,
why we decided to put flour over eggs instead of eggs over flour.
that's a good point. I actually did that intentionally because this is actually the same if you just do this way. This is exactly the same thing. Since you are taking the ratio, this actually means the same thing. Obviously, you need to have the same ratio as I said. That means if you're taking flour over egg on your left, you need to have the same on your right as well, and vice versa. So if you take egg over flour, you need to take egg over flour as well. That's a good question. I actually wanted someone from you to ask this. Thank you. So you can take any way as you like, as long as you are keeping the consistency. That means you are doing the same thing on each side. That's fine, because this is the ratio. This is actually giving us the idea of what would have happened if I have just changed the number to this and that. Okay, just the that's the beauty of ratio. All right, so whichever you solve, you'll get the same result. But solving is not the difficult part. The most difficult part would be to find this relation. Any question from this? Looks like all fine. So if I solve it, let's go for this one, because I set that up. So now if I cross multiply it, it will be 2 times x, 5 times 1. So I'll have 2x equals 5. So if I divide both sides by a 2, we'll have 2.5. So 2.5, for 5x, we need 2.5 cup of flours. 2.5 cups of flour, rather. Sorry for that. Okay, so that's our answer. Okay, any question from this? The exam would be pretty similar, let me tell you. I'm just spoon feeding you the exam, literally. The exam will be just similar to these problems from the home exercise and the examples. All right, just spend a little bit of time on these problems, try to solve it by your own. Okay, and then if you have the solution, if you have the final result, just try to match that, whether your idea worked or not. So, and I think you should be there for the exam. Okay. All right, let's solve one more before we wrap up today. Okay, let's do the last one, exercise 40. Although it won't be in the free response question, that's for sure, but it could be a problem in the multiple choice problem, okay? Multiple choice question could be like this, where you don't need to show your work, but you need to pick up the right option. So let's go for that. A chain weighs 10 pounds per foot. So we can write like this. All right. How many ounces will 4 inches weigh? Okay. So this clearly means we need to know the conversion from pound to ounce and from feet to inches, or vice versa, right? We need to know this. And fortunately, as I said, you can keep a sheet of formula and you can use that during your exam. Okay, so how should you go for it? What's the first thing comes into your mind when you eyeball this problem? Okay, let me see. Nathan, are you here?
Yep.
Okay, so what should you do from here on? Oh, sorry.
Shouldn't you, are you just asking for stuff you should keep on the sheet?
No. I mean, what should you do with this problem?
10 pounds per foot. So you're converting pounds to ounces and then feet to inches?
Right, so I have 10 pounds. So if I convert this to ounces, how much should it be?
160 ounces, I think, isn't it?
Right.
It's ounces to the pound.
And 1 feet is clearly 12 inches. Okay. Okay. So we have converted it. Now what should we do? We're looking for the weight of that chain when its length is 4 inches. Anyone else? So without wasting any more time, I'm going for it because I'll run short of time. So for 160 ounces, let me use the opposite direction. It will be easier to understand. For 12 inches, it will weigh 160 ounce. For 4 inches, how much will it weigh? And that's the unknown part, so we have set this to x. Okay. So once again, this is the most important part, to set this up, set up the equations to set this properly. Okay, so we have taken the ratio of length and weight on both sides, of course. So if I solve it, I'll have 12x equals 4 times 160. I'll keep it like this because I'll cancel those in the next step. So if I divide both sides by 12, I'll have 160 over 12, and 4 goes 3 times into 12, and 160 over 3, I don't think 3 goes to 160, so it will have a fraction. Let me use my calculator. 160 over 3, yeah, it's 53.33. So 53.33 ounces. Okay. Okay, any question from this one? No questions at all? Okay then, so let's wrap it up today. You will have your exam on Monday, just in the same schedule when we meet for the regular lecture. Um, During the weekend, you can send me emails before 12 a.m. in the morning, of course, and I'll try to reply as soon as possible with the solution and or any suggestions for you. And for the exam, once again, a quick suggestion would be to go over the examples and exercises, spend time on those, try to solve those by your own. Have the sheet of formula in front of you, have it written well before you appear for the exam so that you have a fresh mind to go for it. Um, and I think you should be doing fine. Okay, so best of luck for that. And I'll see you guys on Wednesday unless you need any help on Monday. Okay, take care.
Thank you.
Thank you.